Okay, we're going to complete our last lesson here in the first module of AP Macroeconomics, Trade and Comparative Advantage, Part 2. And I want to start by thinking a little bit about what we learned in our last lesson. In our last lesson, we learned that countries with a comparative advantage, or in other words, an advantage in opportunity cost for a good, should produce that good and trade it for goods in which they don't have a comparative advantage. And if they do that, then actually everybody involved in that trade will benefit. And the reason is because each side is trading a good at a cheaper cost or a lower opportunity cost than they could produce on their own. Now, when we did this yesterday, we expressed this problem very simply. You may remember this problem from our last lesson. The United States was producing cheese and pie, as was France. We learned that U.S. could produce 5 cheese or 10 pie, and France could produce 2 cheese or 8 pies. And we also learned that the opportunity cost of producing cheese for the U.S. was 2 pies, and the opportunity cost of producing cheese for France was 4 pies. And since the U.S. had a lower opportunity cost for producing cheese, it had the comparative advantage in producing cheese. And since the U.S. had a comparative advantage in cheese, we knew that France had a comparative advantage in pie. Okay, that's a good review. Now, what you're going to notice about that is that this problem expresses the information in terms of what's being produced or what's being put out. How much cheese can be made, how much pie can be made. And we're assuming that equal resources are going into doing that. Could this problem be expressed differently? And as it turns out, the answer is yes. Suppose we could express it like this. Instead of saying how much we're getting out, could we say how much do we need to put in to get cheese and pie? So in this example, what we're saying is in order to get 1 piece of cheese, the U.S. needs 2 hours of time. And in order to get 1 piece of pie, the U.S. needs 1 hour of time. As opposed to France, who needs 4 hours of time to get cheese and 1 hour of time to get pie. And it turns out the opportunity cost for both is the same. And if you look at it, think of it this way. Look at the United States and their ability to produce cheese. Well, if they took 2 hours to produce 1 cheese, how much pie could they have produced? Well, if pie only takes 1 hour to produce, they could have produced 2 pieces of pie in that time period. And so the opportunity cost was 2 pies. For France, if they chose to use 4 hours to produce 1 piece of cheese, and pie only takes 1 hour to produce, how much pie could they have produced in that same 4 hours? Again, it's 4 pies. This is the exact same problem, just expressing the information in a different way. Now, the problem at the top is the most common problem the College Board asks. It's typically been the one on the free response questions. The one on the bottom is usually reserved for the multiple choice and is less common, but it's worth just doing 1 or 2 to make sure that we're comfortable with it. So let's try one together. Instead of, again, thinking about output, we're going to think about input. So here's a table. We're going to make a chair and a table. And in this case, Lamont needs 5 boards to make a chair, or 10 boards to make a table. And Brian needs 6 boards to make a chair, or 30 boards to make a table. Now, the trick to answering this question is to think backwards. Now it's really about how much you put in instead of how much you get out. So, what's the definition of absolute advantage? The absolute advantage is someone who produces a good with less resources. So, in Lamont's case, he produces a chair with 5 boards, Brian takes 6. So Lamont has the absolute advantage in chairs. And in the second case of tables, Lamont produces tables with 10 boards, as opposed to Brian, who produces it with 30 boards. In that case, Lamont is again using less resources, and so he has the absolute advantage also in tables. Lamont has the absolute advantage in both, because in both cases he needs less resources. The question now is, who has the comparative advantage in producing tables? And to do that, I'm going to again zoom out as I've done before, just so that it's a little easier for us to. Okay, so let's think about the whole issue of opportunity cost of the tables. Well, let's start with Brian. Brian right now needs 30 boards in order to produce a table. He can also use boards to produce chairs, but for chairs he only needs 6 boards. So really what we want to know is the opportunity cost of one table. What does Brian give up if he decides to produce a table? Okay, so he uses 30 boards to produce one table. Well, how many chairs would those same 30 boards have made? Well, if each of the chairs requires 6 boards, and he used up 30 boards, it seems to me he gave up 5 chairs in the process. Now, that's essentially the answer, and I hope that everyone is sort of seeing what's happened there. But if you're not exactly sure, in a problem like this, there is a quick mathematical trick that I'm going to show you. Though again, I do want you to understand what's going on. Let me say it again. Since he used 30 boards to produce one table, he could have used those same 30 boards to produce 5 chairs because each chair required only 6 boards. Again, to make sure you see the difference, mathematically, here's a quick trick. What you'd want to do is get rid of the word boards. Put the 30 in the numerator this time, which again gives you 1. And in this case, over here, again, get rid of the word boards because now you're essentially changing this from the input to the output. Divide both sides by 30. Sorry, throw 30 in the numerator now instead of putting it in the denominator. And you end up with the number 5. That's just a little mathematical trick. It's not a big deal. Let's do the second one to kind of give you a little bit more help. Let's look at this one. Lamont needs 10 boards to produce one table. Well, chairs only require 5 boards. So again, if Lamont uses 10 boards to produce a table, how many chairs is he not producing? He's not producing 2 chairs. And again, if you want to see a quick mathematical trick to make sure that's clear, what we'll do is, again, we'll put the 10 in the numerator this time, which would equal 1. And again, over on this one, again, we're going to put the 10 in the numerator. And you can see how the ratio works out. But again, that's sort of a mathematical trick. What I really want you to see is what's happening. Okay, so what do we have? Who has more of an opportunity cost for producing tables? It looks like Bryant does in this case. So Lamont has the comparative advantage in producing tables. Brian gave up 5 chairs as opposed to Lamont only giving up 2. All right, good. Let's do an example together. I'm going to blow this back up to the large screen. Okay, what I'd like you to do now is try one on your own. Again, stop the recording, give the problem a try, and when you're ready, click play and we'll go through the answers together. Okay, so here we go. The first question is, who has the absolute advantage in strikeouts? Or again, in other words, who's using less resources? Well, in this case, the Mets only use 3 pitches. The Yankees use 4. So the Mets have the absolute advantage because they use less resources. In question 2, it says, who has the absolute advantage in ground ball outs? Well, again, the Mets only use 1 pitch. The Yankees use 2 pitches. So again, the Mets have the absolute advantage. In other words, the Mets are getting the outs with less resources than the Yankees are. So they have an absolute advantage in both. The question now is, who has a comparative advantage for strikeouts? Well, as you can see there, I have opportunity cost of strikeouts. Well, what is the opportunity cost of a strikeout? Well, what are we giving up if we get a strikeout? Well, the Mets will have to use 3 pitches to get a strikeout, as opposed to only 1 pitch to get a ground ball. So if the Mets choose to use 3 pitches to get 1 strikeout, they could have gotten, it looks like to me, 3 ground ball outs at the same time. The Yankees, on the other hand, need 4 pitches for a strikeout or 2 pitches for a ground ball. Well, if they decided to use 4 pitches to get 1 strikeout, in that same time, they could have got, it looks like, 2 ground balls because 2 pitches is half of 4 pitches. So they could have gotten 2 ground ball outs. It looks like in this case, the Mets gave up more for a ground ball out, and so the Yankees, for a strikeout, so the Yankees have the comparative advantage in strikeouts. Answering question 3. And since the Yankees have the comparative advantage in strikeouts, We know that the Mets, for number 4, must have the comparative advantage in ground ball outs. And then number 5, then, if they traded, the Yankees should produce strikeouts, the Mets should produce ground ball outs. All right, there's one last topic I want to cover in this unit, and that has to do with exactly how much we should be trading. And that's what we call terms of trade. Now let's start with a little bit of information about this. Again, let's go back to this example we've used a number of times, the US and France and their whole situation with cheese and pie here. Well, we've already determined that the US, because it gives up less pie to produce cheese, should produce cheese. And France should produce pie, and they should trade, right? We remember all that good information. The question is exactly how much should each country trade in order to get a deal that both would consider fair, that would bring both to the table. That's what we call the terms of the trade. And what is the definition? The definition is the amount of a good traded in exchange for one unit of another good. So here's the deal. For both sides to agree on terms of trade, our rule is the amount traded for one unit of a good must be in the middle of each country's opportunity cost for that good. Well, let's see what we mean by that. Well, remember, what do we know? We know that because of comparative and absolute advantage, or actually just because of comparative advantage, the US produces cheese and France produces pies. Well, look what it says. For one unit of a good, we must be in the middle of each country's opportunity cost. So we know the opportunity cost of cheese. 2 pies for the US and 4 for France. Therefore, a reasonable term of trade would be the following. For every 1 unit of cheese produced by the US, France must return 3 pies. And again, you notice that 3 pies is between or in the middle of the opportunity costs of the US, which is 2 pies, and France, which is 4 pies. Now, why does that make sense? Why does that work? Why, in this case, does 1 cheese for 3 pies make sense? Well, here's why. The US isn't going to accept 2 pies or less for cheese, because think about it. What is already the US's cost for 1 piece of cheese? 2 pies. So the US is going to say, listen, we're not going to trade unless we get back more than what we could produce on our own. By the same token, France's cost for cheese is 4 pies. So France isn't going to make this trade. All by itself, its cost, I should say, is 4 pies for 1 piece of cheese. So France isn't going to make this trade unless it can give away less pie. In other words, unless its cost is less than 4 pies. So the US won't accept less than 2 pies, but the French won't give away 4 pies or more. So what's a good solution? Something in the middle. But 3 pie for 1 cheese works. Why? The US gains 1 pie over what it could do by itself, and France gives up 1 less pie for cheese than it could by itself. So we're going to look for a situation where for every 1 unit of something, we're going to exchange in the middle of the opportunity costs of those 2 countries. So let's do an example. Here's our friends Brian and Lamont, and remember that Brian has the comparative advantage in shares and Lamont has it in tables. This was our information we had before, okay? And we figured out that Lamont had an opportunity cost of 2 chairs for a table and Brian had an opportunity cost of 5 chairs for a table. So what would be a term of trade that would be fair to both? Again, if you want to stop for a moment, pause the recording and figure out your answer. Okay, what would be a deal that each could agree on? All right, well, we know in this case that Lamont is going to produce the tables because he has the comparative advantage. So for every 1 table that Lamont produces, how many chairs can he ask for and how many can he expect to get back from Brian? Well, one answer might be that Lamont gives 1 table in exchange for 4 chairs. And again, why does that work for both? Well, in Lamont's case, his cost of producing 1 table is 2 chairs. So he's going to expect to get more than 2 chairs back. In Brian's case, he's giving away the chairs in exchange for that table. He already gives up 5 chairs on his own, so his expectation is that he's going to give up less chairs. So somewhere between 2 and 5 chairs is where they're going to have to work this out together. 4 seems like a pretty good answer. Of course, obviously, 3 would also have been a good answer. And the negotiations between the two guys as to which one they choose is not really a part of this class. But we know they're going to end up somewhere between 2 point something and 4.99999. Presumably they don't want pieces of chairs or pieces of tables, so the best options here would be 3 chairs or 4 chairs.